In this video, we're going to discuss different types of discontinuities and how to classify them. So here we have three different pictures showing three different types of discontinuities. Our first category are jumps, and that's when, let's say, we're cruising along here from the left side, and then all of a sudden the graph jumps down on the right side. So that would be considered a jump. Second category are holes in the graph, where you're cruising along and then you have an undefined point, otherwise known as a hole, and then we continue. And then there's vertical asymptotes, where you might have an imaginary line that the graph approaches but does not touch. So let's take a look at these types of discontinuities. So directions for all three examples: find all discontinuities and classify them. And in example 1, here we have a rational function. And to find the discontinuities, the first thing we do is we set the bottom equal to 0. Well, that can obviously factor as x plus 3, x minus 3. And so our discontinuities would be at negative 3 and positive 3. We would now like to classify what types of discontinuities they are. Well, if you notice, the top also has an x plus 3, which means we could remove that discontinuity. Well, so if we have a removable discontinuity, that means there's a hole in the graph. Now, the other portion that was a 0 on the bottom is a non-removable discontinuity, and that would imply a vertical asymptote for our graph. Let's do another example. Same directions, and this time when we set the bottom equal to 0, it again factors x plus 1, x minus 1. So we know we have discontinuities at negative 1 and positive 1. We're not quite sure what kind they are, so we look to the top. The top factors as x minus 2, x plus 1. Well, so we can remove one of those. So the x is negative 1 value, again, is removable, which means there's a hole in the graph. The positive 1 was non-removable, means we have a vertical asymptote. Now, students frequently get confused or concerned about what to do with the x minus 2 on top. Well, when the top is equal to 0, those are technically x-intercepts. And an x-intercept has nothing to do with whether it's defined or not defined, whether it's a discontinuity or not. So that x minus 2 we can ignore for now, but know for the future that that means at x equals 2, the graph is going to cross the x-axis. In our third example, notice we have a piecewise function, and it's piecewise functions that give us jumps. So again, we're going to take a look at this and try to figure out whether there's a jump or not. So to the right of 1, the limit as x approaches 1 from the right is x squared plus x. To the left of 1, limit as x approaches 1 from the left is 3x. And what we're going to do is compare those two. If they're the same value, then there is no jump. If they're a different value, then the graph jumps at that moment. So when I plug in my 1 to my top limit, I get a value of 2. When I plug in my 1 to my bottom limit, I get a value at 3. Since these two values are not the same, we have a jump discontinuity at x is 1.